We just saw about the case studies and the basics about reverse engineering. Now move on to the definition of reverse engineering. So reverse engineering is the process of redesigning. So okay, redesigning an existing product to improve. Actually, the performance will be improved. Okay, the redesigning means the we going to enlarge its functions and quality to increase the useful life. So this is coming under reverse engineering techniques. The main of this reverse engineering is to reduce the manufacturing cost. Okay, the manufacturing cost is the prime one in developing the product, right? So manufacturing cost will be reduced by surely the with the use of reverse engineering. We have to minimize the manufacturing cost of the new product, making it competitive in market. So actually we redesigning the product, right? So it will be competitive in market, obviously. So the duplication is done without the aid of drawing documentations or computer model. So any three-dimensional computer model or whatever the drawing documents. Okay, so this will be used in reverse engineering to recreate or redesigning the product. Okay. Okay, so why reverse engineering? This is the prime thing we should know about. Okay, reverse engineering. So the original manufacturer has already told that the original manufacturer of a product no longer produces the product. So in case of old Maruti 800 watts, we the manufacturer no longer produces the existing product. Okay, so these cases reverse engineering come into picture. So we have to scan, for example, we are in need of some Maruti 800 watt, means we have to scan the old spares. After that, scan the old parts. We have to create 3D model. After that 3D model, we transfer into any manufacturing systems to create the Maruti 800 parts. Okay, so in that case, we use the reverse engineering come into picture. The original manufacturer no longer exists. For example, in case of Dynora TVs, okay, Dynora TVs, the manufacturer that no longer exists. So in such cases also reverse engineering will be used. The original design documentation have been lost or never existed. So in case of any fire accidents or whatever, maybe the disaster thing. So in this case, the design documentation purely lost. Okay, so in this case, reverse engineering is also used. Uh, again there is an inadequate documentation purpose. So insufficient documentation of the original design. So in this case also reverse engineering will be used. Some bad features of an okay any design. So in need of redesigning the bad features, we have to redesigning the parts, right? So in this case reverse engineering is also useful to analyze the good and bad features of competitor product. Okay, this is the prime thing, that is benchmarking a product like that. Okay, so to analyze the, for example, if consider this case study. If A is the Ashok Leyland and B is the Tata. So in the Tata needs to analyze the good and bad features of Ashok Leyland, means they have to scan its product. After that, they have to find what are the good and bad features of that. So in case of good features, they have taken from that and adopt for their purpose only. Okay, so in case of this purpose, reverse engineering also used to gain the competitive benchmarking, as already told that. So the original CAD model is not sufficient to support the modifications. So in case in need of for example, the CAD model is very old. Okay, now we are using some advanced version, right? So this kind of problem, this kind of scenarios also reverse engineering will be used. Okay, so for these are the reasons we are going to use reverse engineering. Okay, this is a typical workflow of reverse engineering. First of all, the object will be scanned using three-dimensional scanning machines. After that scanning, it detect futures and some cloud points have to reconstruct that. So after the reconstruction, data will be given to CAD modeling softwares. So if CAD modeling softwares, it will be corrected and it transfer into any CAM systems or any RP systems. Okay, so this steps is very important to create the prototypes or exact model. So after CAM missions, it will be transferred into CNC machines. After CNC machine, the finalized product or mode will be done. Okay, so this is a typical workflow of rapid prototyping. Let's move on to reverse engineering tools. These are the reverse engineering tools. So either we using in order to scan the data, we going to use CMM means coordinate measuring machine, or any 3D three-dimensional scanner, 3D printer for creating prototypes, laser sintering also creating the prototypes. Okay, Here the one engineer is scanning the old model. Here you can exactly see here. So 3D laser scanner using extensively for reverse engineering. Okay, this is the 3D scanning machine. Okay, so let's move on to reverse engineering process. It has four steps. So first of all, digitization of the object, digitization of the data capturing using CMM or scanner. So a lot of times I already told that we have to scan the data like that. So this wooden part, this is the pattern, or the original part. We consider this is the pattern or original part. So the original part will be recreated by using three-dimensional scanner. This is the cloud points of that wooden pattern. After that, the cloud points will be transferred into 3D three-dimensional model. Okay, processing of a measured data. So this is the measured data. It will be processed in three-dimensional modeling software. After that, three-dimensional modeling software will be transferred into any RP machines or rapid prototyping machines in order to create the fabricated part. Okay, so this is the these are the four steps in reverse engineering process.